Okay, so let's give a go at some trigonometry problem solving questions now. Okay, so first off, this is genuinely something that I had to do on my degree. Now, some of you might know that I don't actually have a maths degree. My degree is actually in civil engineering. So once, what we had to do, we had to measure the height of this tower in a random park in Loughborough, and we had to find a way about how to do it. Okay. Now, of course, we couldn't just go up to the tower and get a tape measure and see how tall it was, because that was, well, we didn't have any tape measures long enough. We didn't have any surveying equipment, and we kind of had to improvise a little bit. So this is what we did. Okay, what we did, we stood 10 meters away from the base of the tower, and we measured the angle. We had a look. We measured the angle from where we were stood up to the top of the tower. We just kind of estimated it. It was a very, very broad, very, very imprecise kind of angle measurement. Okay, we found that it was 57 degrees there. And from that, we could find out how tall this tower was. Okay, you might notice this is a right angled triangle. Okay, so we don't know how long this bit is. We're trying to find out how tall the tower is, and we knew that the length of that base there, that length there. Okay, so let's label these sides, shall we? This side here is next to both of the angles, because there is a right angle there, remember. So that's our adjacent. This is opposite, and so we used tan to find it out. Okay, so tan of our angle, which is 57. Opposite is on top. Remember these. Opposite's on top, so we're going to put the opposite there, which is x, which is what we're trying to find out, and our adjacent is 10. So tan 57 times by 10 gives us our answer. So tan 57, close the bracket, times it by 10. That comes out as about 15.4 meters. That's what we did on my degree to find out the height of a clock tower. Okay, nice bit of improvisation there. Okay, here's another problem solving question for you. You might notice this isn't a right angle triangle. This is an isosceles triangle. Okay, if that's 5 meters, that's going to be 5 meters as well, because it's isosceles. We've got to find out what this base is here, the length of this. Have a think about how you might do it. This is how you do it. Okay, with an isosceles triangle, you can split it directly down the middle to make 2 right angle triangles. Okay, so we can completely ignore 1/2 and work this out. Okay, if it's split exactly down the middle, this angle here is half of 70, which is 35 degrees. Okay, so we can work that out. I might just do a quick sketch down here just so that it's a little bit clearer in my mind. So that's 35 degrees, that's 5 centimeters, and we're going to try and find out the base here. Now, of course, we're trying to find out the base, but that's only half of it, isn't it? So we've got to filter that in at the end. Okay, so I'm just going to call it, I'm just going to put a box there for now. You might call it Y, you might call it Z, you might call it A, you might call it something else. Okay, let's label the sides. Okay, so this is our opposite. That is our, what is it? There's our hypotenuse. Of course, it's the longest side. Okay, so which one has O and H? This one here, sine. Okay, so we've got sine 35. Sine 35 there. We've got the opposite, which we're trying to find out. We don't know what that is. And we've got 5 as our hypotenuse. They're next to each other, so we're going to multiply. Sine 35 times 5. That comes out as, let's see, sine 35 times by 5 comes out as about 2.9 centimeters. Of course, we're trying to find out the whole base, so if we times that by 2, we should get about 5.8. So times that by 2, we should get 5.7. So 5.7 centimeters, and that's that one done. Okay, here's another question for you. We've got a plane that's travelling from Heathrow. It's taken off from Heathrow and it's gone in a complete straight line from Heathrow. We've also found out that it's exactly 100 miles north of the centre of London. Okay, the question here is we've got to find the bearing of the aeroplane. Okay, let's find the bearing of the aeroplane, shall we? Make it a right angle triangle. Okay, now if we're trying to find the bearing of the aeroplane, we've got to see how it is from north. Okay, clockwise from north, if you remember what bearings are. Okay, so there's north. We could put north there as well. We could put north, well, north is already written there. We could put north anywhere. Okay, so what we could do, if that's a right angle there, that's a right angle for all of that as well. But of course, that's not inside of our triangle. We could find out what that angle is first and then take it away from 90 degrees, couldn't we? So let's do that. Right, let's label the sides. So we've got our hypotenuse and we've got the opposite again. There's a lot of sine today. I don't know why. I'm neglecting cos a lot today. So we've got the O, we've got the H. What is O and H? We're going to be using sine again. So sine, I'm going to call that x. Sine x is opposite over hypotenuse. So we're going to use inverse sine of 100 divided by 120. See how that comes out. See what the angle is there. So inverse sine, shift sine of 100 divided by 120. That comes out as 56.4. 56.4 degrees. Okay, now remember we want the bearing, so we want this one here. So let's take it away from 90 degrees. 90, take away 56.4, and that's going to be, so 90, take away 56.4 is going to be 33.6 degrees. Is that a bearing yet? No, not yet. It's 033.6 degrees, and that's our answer. A couple of trigonometry problem-solving questions for you. Hope I've explained them all right. If you have any questions, please let me know. Thank you very much.